Hello, everyone. Now I'm going to teach section 3.6, derivative of logarithmic functions. So the derivative of logarithmic functions, so the derivative respect to x of natural log of x is equal to 1 over x. The derivative respect to x of natural log of function of f of x is equal to 1 over f of x times f prime of x. So the derivative of respect to x of natural log of f of x is equal to 1 over f of x times f prime of x. And then the derivative of respect to x of log base a of x is equal to 1 over x times natural log of a. And then the derivative of respect to x of log base a of function f of x is equal to 1 over f of x times natural log of a times, again, f prime of x. So these are the original rule, as I told you guys before. They're on the left-hand side. So the derivative with respect to x of natural log of x is 1 over x, and so on and so forth. The derivative with respect to x, e to the x is equal to e to the x. And the derivative with respect to x of a to the x is equal to a to the x times natural log of a. And then the right-hand side, the generalized rule for the chain rule. So the derivative of respect to x of natural log of u is going to be 1 over u, and then I'm going to take a derivative of u, that is du dx. That means the derivative of function u with respect to x. And then the derivative of respect to x of natural log, the log base a of u, the log base a of u is equal to 1 over u times natural log of a times, again, derivative of u with respect to x, and derivative of respect to x of e to the u is equal to e to the u times the derivative of u with respect to x, du dx. And then the last one, the derivative of respect to x of a to the u is equal to a to the u times natural log of a times, again, du dx. Okay, so now let's do some problem together. So let's see. Let's do the differentiate y equal to natural log of x cubed plus 1 based on what we just discussed about like a couple of minutes ago. So the y prime is equal to 1. So the y prime, the derivative of natural log of x cubed plus 1 is going to be 1 over x cubed plus 1, and then times the derivative of baby. So again, the derivative of mother is going to be 1 over x cubed plus 1 times derivative of baby, so x cubed plus 1. So x cubed is going to be 3x squared, and 1 is 0, so it's going to be 3x squared. And then if I multiply this, so it's equal to 3x squared over x cubed plus 1. So the derivative of y equal to natural log of x cubed plus 1 is going to be 3x squared over x cubed plus 1. So now let's go to next example. So find the derivative of respect to x of natural log of sine of x. Again, I'm going to take a derivative of mother, the natural log of sine of x, and then the derivative of baby, that is sine of x. So the derivative is equal to, so the natural log of sine of x is going to be 1 over sine of x times, and then the derivative of baby sine of x, the derivative of sine of x is going to be cosine of x. But look, when we multiply, we have cosine of x over sine of x. Cosine of x over sine of x. Cosine of x over sine of x is actually cotangent of x. So the derivative with respect to x of natural log of sine of x is equal to cotangent of x. So now let's go to next example. Differentiate f of x that is equal to log base 10 of 2 plus sine of x. So again, I'm looking for f prime of x. So based on the formula that I showed to you guys at the beginning of the lecture, so the derivative of log base 10 of 2 plus sine of x is equal to 1 over 2 plus sine of x, 2 plus sine of x times the natural log of base, that our base is 10. So the natural log of 10 times, now I'm going to take a derivative of baby, 2 plus sine of x, so 2 is 0. And then the derivative of sine of x is cosine of x. So the answer is cosine of x over 2 plus sine of x times natural log of 10. And again, guys, how I find this? So because of this derivative of respect to x of log base a of x is equal to 1 over x times natural log of a. So I follow that property, and then we do this problem. So the answer, the f prime of x is going to be cosine of x over 2 plus sine of x times natural log of 10. Okay, so now let's do another one. Okay, this is a good one actually. So find the derivative of respect to x of natural log of x plus 1 over the square root of x minus 2. So actually, I'm going to just again take a derivative of mother. So it's going to be equal to 1 over x plus 1 over a square root of x minus 2. And then times the derivative of baby, that is going to be derivative with respect to x of x plus 1 over square root of x minus 2. So now let's see how we do this. So I'm going to take this derivative. So let me actually erase this. So I'm going to take a derivative of x plus 1 over square root of x minus 2. So now let's see how we do this. Okay, so to take a derivative, again, I'm going to draw a big line. So again, the denominator, so it's going to be a square root of x minus 2 squared. So when I square it, actually the square root is cancel out. So what's remaining is just x minus 2. Now let's go to the numerator. So second times derivative of the first. So x plus 1 is going to be 0 and x is 1. So it's going to be just 1 minus first derivative of second. So the derivative of second, again, the square root of x minus 2 actually is x minus 2 to the power of 1/2. So the derivative is going to be 1/2 in front, x minus 2 to the power of negative 1/2. So now, if I look at this, so 1 divided by x plus 1 over square root of x minus 2. So actually we flip this denominator. So it's going to be a square root of x minus 2 over x plus 1 times, so a square root of x minus 2 times 1 is going to be just so a square root of x minus 2 times 1 is just a square root of x minus 2, and then minus, okay, so since this is 1/2 times x minus 2 to the power of negative 1/2, I'm going to bring this to the denominator. So my numerator is x plus 1 over, so square root of x minus 2 times 1 is the square root of x minus 2, minus, then x plus 1 is going to be in my numerator, and then 2 times the square root of x minus 2 over x minus 2. So now let's see what happened. Let's see. Okay, so now okay, guys, now you see that now we have a square root of x minus 2 over x plus 1 times square root of x minus 2 minus x plus 1 over 2 times the square root of x minus 2 over x minus 2. So I want to kind of distribute this inside of the this parentheses. So and the numerator, I'm going to distribute the square root of x minus 2 inside of the numerator, and then x plus 1 times x minus 2. So, okay, so let's do it separately. Okay, guys, if I set So the first one, the denominator again, x plus 1 times x minus 2, x plus 1 times x minus 2. So a square root of x minus 2 times a square root of x minus 2 is going to be just x minus 2, then minus, so again, x plus 1 times x minus 2. So now, if I multiply a square root of x minus 2 times x plus 1 over x minus 2, so what's remaining? So let me just do it here and then I'm going to erase it. So a square root of x minus 2 times x plus 1 over 2 times square root of x minus 2. So obviously this and this cancel each other. So what's remaining is just 1/2 times x plus 1, correct? So it's going to be 1/2 times x plus 1, okay? So now I'm going to combine it. So it's going to be x minus 2 and then minus 1/2 x minus 1/2, because 1/2 times 1 is 1/2. So all over x plus 1 times x minus 2, and then equal to, so now I'm going to combine the like terms. So 1x minus 1/2 x, so it's going to be 1/2 x, and then minus -2 minus 1/2. So again, guys, just do some basic algebra. -2 minus 1/2 is going to be -5 over 2 all over x plus 1 times x minus 2. And then finally, if I multiply both numerator and denominator by 2, so again, I multiply both numerator and denominator by 2, 2 times 1/2 x is going to be just x minus, and 2 times 5 over 2, 2 and 2 cancel out, what's remaining is just 5 over, and then 2 times x plus 1 times x minus 2 is going to be just 2 times x plus 1 times x minus 2. So the derivative respect to x of natural log of x plus 1 over square root of x minus 2 is going to be x minus 5 over 2 times x plus 1 times x minus 2. So this is this one. So now let's go to next problem. So the differentiate y equal to x to the power of a square root of x. So the things that before I take a derivative, I'm going to take a natural log of both sides. So I'm going to have natural log of y equal to natural log of x to the power of a square root of x. So now here I can use the logarithm property. So I can rewrite this as natural log of y equal to, bring this exponent in front, so it's going to be a square root of x times natural log of x. So now I'm going to take a derivative of both sides. So let's start with natural log of y. So if I take a derivative of natural log of y, so again, is going to be, again, take a derivative of mother and then baby, but again, because this is a function of y, because we take it with respect to x, so it's going to be dy dx. The other word is just y prime, and then we take a derivative of natural log of y, that is going to be 1 over y, okay, and then equal to now the other side, we have a square root of x times natural log of x, and again I'm going to use the multiplication rule for the derivative. So it's going to be first times derivative of second. So derivative of natural log of x with respect to x is going to be 1 over x plus, and then second times derivative of first, and derivative of a square root of x again is going to be 1 over 2 times the square root of x. So now let's simplify a little bit more. So it's going to be y prime over y equal to the square root of x over x plus natural log of x over 2 times the square root of x. So now let's do this on the side. So just concern square root of x over x. So I'm going to do it on the side. So it's going to be the square root of x over x. I'm going to multiply both numerator and denominator by the square root of x. So a square root of x times the square root of x is going to be just x over x times the square root of x. And obviously this and this cancel out. So it's going to be 1 over the square root of x. So I can rewrite this as y prime over y equal to 1 over a square root of x plus natural log of x over 2 times the square root of x. So if I multiply both sides by y, so I'm going to have y prime equal to y times 1 over rad x plus natural log of x over 2 rad x. And then again, guys, be careful that at the beginning of the problem, we said y equal to x to the power of a square root of x. So I'm going to change this to y prime equal to x, because y is equal to x to the power of a square root of x times, okay guys, if I want to find the common denominator between a square root of x and 2 times the square root of x, so the lowest common denominator is going to be 2 times a square root of x. So if I want to multiply both of these by 2 times the square root of x, a square root of x and a square root of x cancel out. 2 times 1 is 2 plus, and then 2 times the square root of x times natural log of x over 2 square root of x. 2 square root of x and 2 square root of x is cancel out. What's remaining is natural log of x. So the y prime equal to x to the power of a square root of x times 2 plus natural log of x over 2 times square root of x. And that's the derivative. Okay, so now let's look at this constant e limit identity, that the limit of x approach to 0 of 1 plus x to the power of 1 over x is equal to e. So let's see where that comes from, okay? So please watch me how I'm going to do this. So, okay, guys, look at the e. So e is to the power of 1, correct? So and then is equal to e to the power of limit of x approach to 0 of natural log of 1 plus x to the power of 1 over x. So, and that was equal to 1. Because remember, guys, that before I showed to you guys that on the, if you graph the e, you see that the slope is exactly at 1, correct? So the limit of x approach to 0 of natural log of 1 plus x to the power of 1 over x actually is equal to 1. So now equal to, so now I'm going to use a continuity for section 2.5 continuity formula. So I can rewrite this as limit of x approach to 0 of e to the natural log of 1 plus x to the power of 1 over x. And again, guys, e and natural log is e to the power of natural log. They cancel each other. So what's remaining is just limit of x approach to 0. What's remaining is just 1 plus x to the power of 1 over x. Okay, so it says, oh, Mr. G, how we know this, okay? So how we know that the limit of x approach to 0 of 1 plus x to the power of 1 over x is equal to e. So let's see what happened exactly here, okay? So let's do it. Okay, guys. We showed that if f of x is equal to natural log of x, then f prime of x is equal to 1 over x. So in this case, so f prime of x is 1 over x. So f prime of 1 is going to be equal to 1. Because again, if f prime of 1, 1 divided by 1 is 1. So f prime of 1 is equal to 1. Now we use this fact. We use this fact to express the number e as a limit. So let's do it. So now we use this fact to express the number e as a limit. So now let's do it. F prime of 1 is equal to the limit of h. Let's see. Yeah. Let me erase this. The limit of h approach to 0, then is going to be f of 1 plus h minus f of 1 over h. This is equivalent to the limit of x approach to 0 of f of 1 plus x minus f of 1 over x. So equal to, now the limit x approach to 0. So f of 1 plus x actually is going to be natural log of 1 plus x minus f of 1 is going to be natural log of 1 over x equal to the limit of x approach to 0. So, okay guys, natural log of 1 is going to be 0. So what's remaining is just natural log of 1 plus x over x. So I can rewrite it as natural log of 1 plus x times 1 over x. So actually I can rewrite this as, let me erase it. So I can rewrite this actually. So natural log of 1 is 0. So it's going to be, I can rewrite it as 1 over x times natural log of 1 plus x. Again, guys, I'm going to use the property, and I can rewrite this as a limit of x approach to 0 of natural log of 1 plus x to the power of 1 over x. And then, so f prime of 1 is equal to 1. So I know that the limit of x approach to 0 of natural log of 1 plus x to the power of 1 over x actually is equal to 1. So now you understand why we use when I said e to the 1 is equal to e to the limit of x approach to 0 of natural log of 1 plus x over 1 over x is because of this. So now, so because f prime of 1 is equal to 1, then the limit of x approach to 0 of natural log of 1 plus x to the power of 1 over x is equal to 1. So that's why. So now let's go to the last part of the lecture. The number e as a limit, if we put n equal to 1 over x in formula 5, then n goes n approach to infinity as x approach to 0 from the right. And so an alternative expression for e is equal to limit of n approach to infinity of 1 plus 1 over n to the power of n. Okay, let's go over this. So where we get this, okay? So let n equal to 1 over x. So if I play with this and solve for x, so n is equal to 1 over x. If I want to solve for x, then it's going to be x equal to 1 over n. So look, if x approach to 0, then n goes to, so if x approach to 0, n goes approach to infinity. So now with all these information, so the limit of x approach to 0 of 1 plus x to the power of 1 over x that I explained to you guys in previous slide. So this is actually is equivalent to limit of n approach to infinity of 1 plus, and again guys, x is equal to 1 over n, and then to the power of 1 over x is n, so it's going to the power of n, and that's equal to e. Okay guys, that's it. This is the end of the section 3.6, and hopefully you guys enjoy this. And again, please guys, make sure if you have any question, let me know on Wednesday when we do online session. Again, I'm going to use discussion board. So thank you guys and have a beautiful day. Thanks.